Here I am given two functions, f of x equals 2x plus 3, and then g of x, which we're given this table for. And we're asked to evaluate each of the following expressions. So first thing that I'm going to do for a here is g of negative 3 is when I plug in negative 3, g of negative 3 is 3. So this becomes 3 over, and then f of 1, so 2 times 1 plus 3, which is 5. So a is equal to 3/5. Next one, I'm going to be plugging in f of 2. So down here I got 2 times 2, which is 4, plus 3, which is 7. And then g of 2, which is just 1. And so that tells me that for b, I get 7 plus 1, which is 8. Next one here, f of g of 2. So first things first, I'm going to work inside out. So g of 2 is equal to 1. So I'm really saying f of 1. And when I plug in 1 into my original equation up here, 2 times 1 is 2 plus 3, which is equal to 5. Second row here, I got g of the inverse of f of negative 1. And so what that means here is that I'm going to go ahead and quickly find the inverse equation here, and that's going to be x equals 2y plus 3. Subtract 3 from both sides, divide by 2. There's my inverse function of f. And so f of negative 1 would be plugging in negative 1 into here, which becomes negative 4 over 2, which is just negative 2. So now I just did that part, g of negative 2, which in this case is equal to negative 3. A little bit of chaos here because there's lots of steps and individual pieces to this problem, but I hope you're following along here. So just to do the next one here, I have g, the inverse of g of 0. So really, like when I plug in 0 into the opposite side, I get 3 here. So I'm saying f of 3, which when I plug into f of x, 2 times 3 is 6, 6 plus 3 is 9. And last one here, f of negative 3, which when I plug in negative 6 plus 3 is negative 3. So I'm saying the inverse of g of negative 3, which is when I plug in negative 3 on this side, it spits out negative 2.